Lesson 14.14 is solving exponential growth and decay functions. So it's using exactly what we've done before with making the equations, but now we're solving for t, which is the exponent. So it becomes an exponential equation that we're trying to solve for. And solving for an exponent will require us to use logs. Number one, a town has a population of 19,000 people. It's growing at a 4.5% rate every year. To the nearest year, how long will it be until the population will reach 51,600? So remember, our formula is that the final amount equals the principal or the starting amount times the growth rate. And a growth rate, since it's growing, it's going to be a 1 plus the percent as a decimal because it's growing over 100%. And then to the t or the time as your power. So let's put the final amount, which is, they're wanting to know when will it reach 51,600 people. It starts with the 19,000 people, and then it's growing at a 1 plus, percents are out of 100, so you're dividing by 100 or moving the decimal back 2 places to the left, so it'd be 0.045 to the t power, and that's what we don't know. We're trying to find to the nearest year. Okay, add this, and then that just gets 1.045. So now we want to isolate our exponential part, which is this 1.045 to the t power. We wouldn't ever want to multiply these two things because that's not the right order of operations. It goes exponent, then multiplication. So to solve for this, we want to get rid of the multiplication by dividing to isolate this. So that would go away. 51,600 divided by 19,000 is that. I'm going to give it several decimal points here, but I'm actually not going to clear that off my calculator. So I'll say 2.7158. And then I've got 1.045 to the t power. Okay, think about this. This is an exponent. The exponent has a base of this. So to write it as a log, I want log with a base of 1.045 of this number, and then equaling the power t. We're more used to seeing it where it's this equals this. So if it would have helped you to keep it like this, that's fine. And then you could see base of this equals t. So now this becomes change of base. And that'll actually give me t. So I'll have log of this 2.7158 number. I'm going to hit second and then the negative symbol, which is your answer. And then divided by log of 1.045. And it gets 22.7. It says round to the nearest year. So then that would be year 23. Okay, so if you need to write this out, that this is change of base, I'm hoping we see it and we just automatically know what to do to get an answer out of that. All right, let's try number 2. New car is purchased for $23,600. Value of the car, it's depreciating, which means it's going down in value by 8.75% per year to the nearest tenth of a year. How long will it be until the value of the car is $7,100? Similar to this equation, the only thing that's changing is that we have a minus. 1 minus our rate because it's decreasing. It's not going to be itself. It's not 100%. It's less than 100%. And so let's just start with the initial amount of 23,600 times 1 minus the rate as a decimal, which is 0.0875 to the t power, and we want to see how long it will be until it's $7,100. So I'm going to write it this way, hopefully to keep it easier for you to stay consistent. So 1 minus 0.0875 gives me 0.9125 to the t power. I'm going to divide away 23,600 because again I want to isolate my exponential part, which has a base to the power t. Divide 0.9125 to the t power equals about 0.3008. But again, don't clear that off your calculator. Now to write this as a log, be log with a base of 0.9125 of this 0.3008 needs to equal t. So then here you're just doing change a base to be log of that answer, so I'll hit second, the negative button, divided by log 0.9125. And be careful, it says to the nearest tenth of a year, which would be 13.1.